Hey everybody, this is Larry. This is day 17 of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 3 equal parts. I usually solve these live, so it's a little bit slow. I don't know, skip forward, fast forward, whatever you need to do. Today's problem is 3 equal parts. Okay, let's take a look. You're giving zeros and ones, 3 non-empty parts such that all 3 parts or these 3 parts have the same binary value. What does that mean? Okay, what does 0 and 2 mean? If it's not possible, return this thing. Okay. So they just have to be non-empty. They don't have to be equal. They have equal binary values. Okay. That is interesting. In this case, this will be 1, 0, 1, and 0, 1, I guess. 3. Okay. So yeah, so 1, 0, 1, 0, 1. This is an interesting problem. I don't have any numbers off my mind. And the length of the array n is very big. But really, we're looking for the same number, but with a possibility of a prefix 0, right? In this case, this is not possible. In this case, this is 1, and then 0, oh no, 1, 1, and then 0, 0, 1. Let's think about this. I don't really have anything off my head, to be honest, so I'm trying to think about, like, so the things that I would think about, maybe like sliding window, maybe some sort of prefix some e type thing, but that doesn't quite make sense. Some kind of suffix and prefix matching, some weird try-like type thing, but I don't really have one on that either. I mean, it is kind of a weird thing. I mean, I think I have some ideas around. I think I have some ideas around Robin Cobb, but I don't even know if those are good ideas. So this may be a long one for me. I think the annoying thing about some of these problems is that there is one observation that you have to make, and if you're able to make those observations, then it becomes easy. But I'm not making it that this time. But the only thing to note is that other than leaving 0, the suffix after that should be the same. Can we build off that idea? Well, we know that it has to have at least one number, right? Or one digit. So is that enough to get us started on anything? It's a little tricky to be greedy though. Can you be greedy on this? Okay, let's take a look at, can we greedy on this, right? And what I mean by that is just look at the last number and then see if we can figure out the other two. So if this is 1, we could greedy choose 1, but then 0, 1, it's a little bit awkward. If we take 0, 1, then this is still 1, so we match the first one, and then go to the next one, and then see if you can kind of match the rest of it. Okay, so if we do this naively, this will be n squared, where n is the number of digits. But 3 times 10 to the 4th square is probably going to be too slow, so we might have to do something more clever. And the hard part is the stuff in the middle, because we can slide the left and the right thing, but then the middle change in a weird dynamic way, because well, I guess another observation to note is that minus the leading zeros, in order for them to have the same binary value, they would have to have the same number of digits plus leading zero. So that means that, what does that mean? How can we take advantage of this? It means that if we do some kind of prefix sum, the ones will have to be distributed equally in 3 different places. And also that the number of ones have to be a multiple of 3, right? And with that, I think that's good enough for us to figure out the answer, because now we know exactly to where to do it, and also you have the last number, so then you could figure out how to maybe finagle it and the first digit with while you're trying to match the first number and the last number, and maybe play around with that. I know it's a little bit iffy, but I think that's still good enough, because now you're no longer searching on n numbers, you're just searching on, just juggling the leading zeros, which is way easier, right? Okay, let's do that. Let's start playing around with that, and then we'll, get an actual working solution in a second. But yeah. I think that's right, unless I'm mixing up languages, which is, I'm not gonna lie, I do mix up languages a lot, so that's why sometimes you see me running relatively simple code. I think it's just Larry getting my old age. And yeah. Are there multiple answers? I guess it's not really possible to have multiple answers unless they're all zeros. If they're all zeros, there might be multiple answers. If not, then there's no way to have multiple answers. Yeah, that sounds right. Though they don't really talk about this. Oh, no, they still don't talk about this. So we have say, that's not really talked about. Let's just run it real quick just to kind of see what the answers look like. I know I'm cheating a little bit here because you get an expected answer which you wouldn't get from a judge or something like that. But yeah, like we said, this should be what we expect, right? Because we're splitting them into threes. This one's a little bit awkward, might have multiple answers, but I don't know, that's fine. Yeah, then now we go, if once mod 3 is not equal to 0, then we return -1, because it's not possible. And then now we just have to distribute the ones, and we could do that in, yeah, we could do that in a greedy way, right? Yeah, okay. I'm a little bit, I'm trying to think about what I'm thinking about now is just the implementation detail, and it may be a little bit tricky. So let's play around with some really yucky implementation, and then we'll think about optimizing the solution later for maybe a cleaner way of writing it. But I think for now, in the beginning, you should focus on just getting it correct, assuming that the complexity is good enough. In this case, it should be roughly good enough. at worst it should be O of n, even if we're doing it really silly. So yeah, so let's just take code first, second, third, maybe. Is that a good idea? Yeah, but now let's just code parts is equal to 3 arrays, and then now we just go for let's just do count is equal to 0 for x is an array. If x is equal to 1, what's that? Let's do it this way. And then if something like this, maybe. Yeah, something like this should be fine. Let's for testing's sake, let's take a look. Hopefully it doesn't. Yeah, so now we have. Okay, maybe this is wrong actually. So f(1) equals 1. Oh, this is wrong for sure. It should be that counts is mod by with per part is equal to 1 mod dot by 3. So then now, okay, very silly mistake. I'm very tired right now, to be honest. It's very late here in the West Coast. But yeah, okay. This is still very wrong. We want this to be, is it 0? I mean, we do, but maybe afterwards. Because we want to add the thing to it. Okay. And then after that, we have an extra one, but that's fine-ish. Let's just actually, I'm a little bit whatever about the last case. So if there are no ones, then just return 0, 2. So I think that should be a possible answer. Yeah, return any possible. So yeah. So I think that should be a good answer because this is just here, and then we start from here all the way down, right? Okay. Anyway, yeah, in this case, now we have an extra thingy. So let's just pop off the end. I don't know. I'm a little bit, like I said, I'm a little bit tired, a little bit whatever. And then now we can kind of see. Oh, I didn't print it. So only issue. No, actually, I think this should be. No, so this isn't good because you might have a. Yeah, okay. So because you may have an ending 0, right? So you can have something like this, and the answer would, yeah, that's why we still have to do some jiggling. And also it just doesn't return as, oh, because we pop off the extra point. Yeah. And report is less than 3. So then the last one gets order 1. Okay. So now we have a thing, and now we're trying to jiggle them back to be correct, right? What a mess. I mean, I think I'm able to articulate this in English, but getting the the coding part is a little bit more annoying. So leading 0 is okay. So we're trying to count. Then in this case, we're just trying to count suffix zeros. Yeah, I think that should be good then. Yeah, let's give it a try. So then now so here we're trying to figure out how to force the number of suffix zeros, and it only gets forced by the last part, right? So yeah, so now let's just count, and because it's always okay to have more prefix zeros, we just have to count to the count stuff. So suffix zeros is just parts of 2. Well, let's just start at 0. While parts of 2 of negative I yes, I don't like the way to write loops in thingy, but yeah, let's just call it I then, or index maybe. So now we're going from the last one up, and also just let's just I write it in a weird way for Python, but the way that I want to write is this, right? And this looks a little yucky, but that's okay. But this also allows me to write while index is less than length of parts 2. But we should probably cache this in a variable, but that's fine. Yeah. So then now, this is just suffix 0. I guess I could have just done that. Okay, fine. Right. And then now we have to each other part, which, by the definition of how we structure it, will have no suffix zeros. So now we have to add them as much as we can, right? So now, let's just say parts of 1, while parts of, let's see, how do I want to write this? So now, while parts of 2 of 0 is equal to 0. How do I want to write this? I want to pop left and then whatever, right? Let's just use a deck then. I'm using a deck so that I could use pop left, right? So yeah. Oh, need a US. So in this case, we pop off the pop, and then we append a 0 there. That's okay. And here we go needed decrement by 1. If at the end, if needed is greater than 0, then we return it's not possible. Otherwise, we do the same thing, but for shifting from the middle part to the first part. Again, like I said, this code is very yucky, but that's okay. We're just trying to get an understanding, and then once we have more understanding, we can maybe optimize the code. I'm not going to do that probably in this video because I am very tired, but getting it correctly is interesting enough for me, maybe. Yeah, and then if needed is greater than 0 again, we return -1. Otherwise, let's print out the parts. Hopefully we're right up to this point. we're correct up to this point. And yeah, and look, there we go, there we go, there we go. And this should be pretty good. Do we have a case? I feel like I want to test more cases where this is -1, but I think this is really the idea about it. I think just having this, but having this will still give an answer, but having this but missing a 0 would not be good. And then I think this will still be good, and having an extra 0 here should be no good. So let's kind of run this code real quick. Okay, so now the -1 matches, so now let's just do this. And here we can just count the length of the parts. I know that I did this in a very roundabout kind of way, but that's pretty much the idea. So with length of now, it goes from the last element, right? So I think this is good, or part 0 is good, and then this will be, it starts at length of parts of 0 plus length of parts 1. I may be off by 1, but I think this is roughly right. I think actually I'm off by 1 in the first item, because it is inclusive instead of the length. So it should be this -1. And then again, because this is a multi-solution problem, I wish they kind of give us whether we're correct or not. 0, 2, is this right? So 0, 2. Oh, and that's right. This. So let's see. Where does it differ? This one. That's the one that I was looking for. So, okay, that's the 0, 1, which I think is still correct. All the other ones looks good. So let's give it a quick submit. Fingers crossed. Oh no. Okay, so this is not possible, but I thought it is possible. Why is that? Let's take a look. Let's take a look at the parts. So it thinks that, okay. Oh, well. Yeah, I mean, this is clearly wrong, right? I think I just missed out a case. So what I'm thinking is, why did I miss this case? I think I was too focused on the distribution of zeros that I forgot to check the actual numbers. They have, they have the same properties. I think that was my original thought, was that I had to check the numbers at the end, but I think I rushed it a little bit, to be honest. That's my bad. And then I just forgot about this part. I think that's one of the dangers of me kind of doing the slide and explaining my thought process, is that sometimes I'm a little bit slow to get to the end, and then by the time I actually get to the end, I forget some of the steps that I told myself I would do later. I need a better process around that. But anyway, here, I mean, it's pretty simple, to be honest. It's that, okay, now all the zeros match, so then all you have to do is just do a linear scan, removing the prefix zeros to kind of get rid of it. But yeah, let's just say potential is equal to this thing, because we're gonna mess around with the thing as well. But yeah, yeah. So let's see. So while okay, so what we want to do first is just getting rid of prefix zeros, right? The leading zero. So then after that, it should be exactly the same, and then that should be pretty good after that. So yeah, so let's, again, this is pretty yucky, to be honest. Okay, let's just actually, you can do better than that, Larry. So yeah, so let's just do. Okay, right, so now we get rid of the leading zeros. Maybe I should comment. Yeah, maybe not. I mean, you should, but I'm a little bit lazy, a little bit tired. So now we just have to check if the length of the parts are not the same, then we can terminate early. But we have to still check. This time I am, more careful enough to remember it. I should also, you're responsible to, maybe you would write something like impossible is equal to, so that you don't keep on typing it. Though technically the word impossible is actually longer, so whoopsie daisy. I mean, it's the dot and the um, extensibility, right? Like, let's say if they change the error code tomorrow, then you could just change it in one spot instead of like 5 spots like I did. Okay, so now we have to just check it one at a time, right? So yeah, so while length of parts of 0 is greater than 0, because now they have the same length, we can just check if I mean, I know that there's transitive property and stuff like that, but I like to write it out because just because it's I don't know, I feel like for non-community stuff, sometimes you kind of get too used to it and then get it wrong. So yeah, so now potential. Otherwise, we return potential, and I think this should be good. This is basically just going one character at a time for all 3 words or 3 things, and then kind of go through them. Let's give it a spin. Hopefully, it gets it right for this one, and it does. So let's just give it a submit because it's getting late in here. I'm crossing my fingers. Why would this be too slow? That is actually surprising, to be honest. Because this is linear, unless I have a typo somewhere. This should be linear. Okay, so it went for all the cases, but it's too slow. But it still should be linear, so that is a little bit unfortunate. And also now that I clicked forward, I lost all the test cases, so that's actually pretty sad. What if I click on? Oh man, so I really lost all my test cases. This is such a bad experience. Okay, well, let's see. Do I have anything where I am not linear by accident? No, I mean I went for the test cases, so I think this is just a case where um I don't know, the inputs are a little bit too, or there are too many inputs, 118 cases, because we use the sum of execution time. Because everything I do here is linear, right? So we're going to go and now analyze this. This is linear time, linear space, because I do too much pop left and stuff like that. I probably could change the way I handle this, but because I use 3 decks and a lot of this length part stuff, so it's a little bit weird, to be honest, and I'm not gonna lie. But it's really, I'm trying to think about how to do this and clean this up in a way that doesn't require me to rewrite everything, and especially since I lost all the test cases. You can actually rewrite these to just use pointers, to be frank, and that's probably the way you should do it. I'm really tired right now, so I'm trying to think about how to hack it together in a good way. Um, that's kind of sad, actually, but don't know. Let's see. I mean, n isn't even that big. It's only 30,000, right? Yeah. So, like, I don't know why linear time things are so slow in Python, even if I am using using kind of slow stuff, to be frank, on the linear side. But mm, let's see. Okay, I think I saw it. I'm just being dumb. The reason why this time limit exceeded is actually because I have this thing where instead of comparing the first element, I think I just got lazy and I compared the entire array every time after I pop, so it becomes n squared. So actually, there are 2 ways to write it. Now that I think about it, because now that we remove the leading zeros, we can actually just compare them directly. So I think actually I don't even need to write. I just need to do this, and I think we should be okay. because now this compares the entire array, because now they have the same length, they have no leading zeros, and they should all just be the same. So let's give it a submit. Okay, so yeah, so that's good. That was a silly mistake, that's all. Okay, so what is, like, okay, let's make this a little bit smaller. Maybe that's a little bit too small. I was going to say, so you can fit everything on the screen, but let's just go over it again. This is going to be linear time, because for each character in the list, we do constant number of operations every time. For example, here, each item gets added to the deck once. Here, this can only happen n times, way less if you want to do the math, but it can only happen n times because you're just counting the number of suffix zeros. Yeah, and here you can think about it, each number can be moved from part 1 to part 2 once, so that's going to be linear time. Same thing here, or the other way around actually. The number of times a number can go from part 1 to part 0 is constant number of times, so this is still going to be linear. Here it's just popping off the leading 0, and each digit in the array can only be popped once. So again, linear time in total. And let's see, the length is standard. Here we just go through, literally in Python, go for each element of the array, right, and just do a comparison. And we do this 3 times, which is constant number of times per element, or linear time. So if we do this in linear time, linear space. You can actually do this in constant space very trivially. I use dec because I am old and tired and don't want to keep track of all the indexes at 2 in the morning in the West Coast. But you can actually just keep track of pointers, right? You have a pointer for the left part, you have pointers for the middle part, you have the pointers on the right part, and you just have to be a lot more careful. And once you're careful, then you can do basically what I'm doing, but with pointers. And of course, even here, I was not that careful, but that's besides the point. Okay, that's all I have for this one. Let me know what you think. Hit the like button, the subscribe button, join me on Discord. Stay good, stay healthy. To good mental health. I will see you later. See you soon, and have a great weekend. Bye bye.